Good afternoon and welcome. In representation of the Team 5 members, Israel Lezama and Alvarado, Alicia, Arroyo, and Gustavo, Adolfo, Manzanilla, I'll present now to you the industrial rolling up door design and simulation carried out through the usage of the software MATLAB. This as the given resolution to the problem situation corresponding to this formative unit analysis of elements of mechatronic systems. Let's begin by analyzing the operational human-machine interface requirements indicated for each operational method in the problem situation, either manually or automated. Let's begin by analyzing the general requirements for both systems. Here we have three matters: position, velocity, and safety. About position, we know that it must be controlled by the operator. So we may add a display showing the precise position of the curtain, or we can add an input so that the user enters the desired position and the curtain achieves it by rolling up or downwards. About velocity, we know that this parameter shall adapt to a 3 to 5 second lapse for a total closing or opening time to control the accelerations and positions of the curtain system. Finally, about safety, two instructions or requirements were given. The first one, a stop latch button for emergency cases. So while pressing this button, not any further action will be carried out by the curtain system. However, when returned to its unpressed state, the curtain can continue its processes. We also need to identify any obstacle below the curtain. These through sensors. When an obstacle is identified, the curtain must rise to its upper position, start an alarm, rise it up, and send the instruction to record the event to avoid any possible accidents. About the manual operation, three buttons were asked for: an up button, a down button, and a brake button. The up and down buttons shall move the rolling door while pressed. While pressing up, it will go upwards, and same for down, but downwards. About the brake, we decided to automatize the process, so this will not be a button, but when not sending any up instruction or down instruction in the manual operation system, the brake will be activated and the curtain will not move in any of the directions. About the automated operation, we will add a rise or lower button. This will be through a switch that will let the operator to select the desired movement direction. We will also add a brake. This brake will be functioning as an on-off switch, for example, and this will stop the curtain even if a rise or lower indication is given until return to its own state. We also need a constant rolling velocity. This means that we don't want to have any speed level jumps during the operation. So we can have a certain acceleration, but it must be controlled and continuous. We don't want high accelerations or deaccelerations that can end up in a problematic situation in the labor operation. Okay, now let's pass to the analysis of the simulation generated through MATLAB software, which we will see in screen in a second. Okay, so now in screen we see our simulation, but before carrying it out, we will analyze how the system is working. Okay, so first we will choose an operational mode. It's 1 for manual and 0 for automated. This will enter in the subsystem. Then once the 1 or 0 is given, if given a 0, the movement will be automated. So this will send a 1 when wanting to rise up, and as -1 when lowering or going down. Okay, in the manual system, the natural position or natural state of these variables will be a 0. This is the automated brake system, so the curtain will not move. When pressing the up button in the manual operation mode, this will send a number 1 and the curtain will go upwards. When pressing the number 2, this will send a -1 and the curtain will go downwards. This will enter as a 1 or as a -1 in this system. Let's analyze what's happening inside of the system. Okay, so our desired direction enters in the system, and here we have a velocity entering, which is going to be multiplied by a -1 or a 1. So a negative velocity will be going downwards, a positive velocity will be going upwards. This will now pass to the on-off and stop filters. When being a 0 off, the velocity will be multiplied by 0, and then the curtain will not move. When given a 1, it will pass through without any problem. Same case for stop. When being unpressed, it will send a 1 and the velocity will pass without any problem. When being pressed, it will send a 0 and the velocity will go directly to 0. Okay, now after the velocity has entered into this part of the system, it will be entering in this integrator block, transforming it into a position. So this position will be rounded up and will go out to this display. Then with the position and its difference with this setup of the maximum height of the curtain, it will pass here as the required distance to cover. We will also choose an opening or closing time between 5 and 3 seconds. This will be through a sliding switch. So this time is entering here, and we obtain it reciprocal, which is 1 over time. In this product, we obtain distance over time, otherwise called velocity. So we have a speed or velocity here, however you want to see it, without or with the direction. And the system will continue cyclically. This part of the system will be inactive, while this number, which is the obstacle detector, is a 0. When an obstacle is detected below the curtain, well, it will transform into 1, and this system will enter into action. Let's finally analyze how the system is working, okay? So the velocity, which is the same, it's entering on C, A, B, and we also have the direction to know if it's going upwards or downwards. So we are entering the same velocity in all of these blocks, and the direction will determine the carried out action. If our direction is positive, this means if the curtain is going up, well, then the velocity will be multiplied by 0 before entering to the add up. So we will add 0 meter per second velocity. So it will not affect the system because it's going already up and we don't need any changes. If the velocity is entering here and the direction is 0, so it stops, we will multiply it also by a 0. It will continue on its position and won't move. So there's not any important change in here. But when going down, we will have a negative direction. This means that we will enter in this block, and thus the velocity will be multiplied in this product with a negative arbitrary constant to transform it in a positive velocity, as we know the law of minus and plus symbols. Minus per minus is plus, so it will transform into a positive velocity and will go up. So this is in general matters how the system is working. Let's try it out through this simulation, which we are running now. So the curtain is now off. We will turn it up and it shall rise as we will pass to an automatic operation. So the curtain is now rising, and when we ask it to lower, it will lower naturally. Okay, when going up, for example, if we turn it off, it will stop automatically. Or we can also press our stop latch button, and while pressed, this red colored alarm will rise up and not any further action will be carried out by the curtain. We can also see the level of the curtain changing in this display. Well, let's lower it. And when an obstacle is detected, it will go to its upper position and activate an alarm. Now, if our curtain is rising and we detect an object, well, it will continue rising, but will set an alarm. If it stops, nothing will change. Something important about this is that we can choose the closing time. We will see it. Now it's 5 seconds. We'll pass it to 3 seconds. And as we can see, it's now faster than before. This is how the automatic process works. Let's pass to the manual operation mode. Okay, so here when choosing going downwards, it will go downwards and upwards with the up button. Now it's in the brake state. The brake is activated as none of the signals is given. Okay, so when we press down, the curtain is going down. When we stop pressing, it stops. And same case for up. When we press up, it's going upwards. When we stop, it stops too. Now, when an obstacle is detected and we press up, there's not any problem. It will go up as there will not be any incident. However, if our curtain or rolling door is going down and an obstacle is detected, even if we press the down button, it will go up to avoid any accident and the alarm will be rise up. This is how our system works. Thank you for your attention and have an excellent week.